Hey guys, today I'm going to be talking about Drupella snails and their impact on coral reefs. First, I'd like to ask you guys a question. What if all the coral reefs disappeared? Think about it. Some experts predict a world of hunger, poverty, and political instability. It's definitely an issue that should not be swept under the rug. Frankly, this what if question is not some far-fetched scenario. The threats to coral reefs are very real, and you probably are aware of some of which include climate change, pollution, coastal development, and overfishing. However, there's another threat to add on that list that I want to talk about today, and that threat is a snail with the genus name Drupella. Drupella are sea snails that have shells up to 5 centimeters long, which are covered with small spikes or bumps. The color of their shells can vary, but are usually pink, purple to a brownish color. Drupella snails are frequently found in living coral reefs throughout the Indo-Pacific. Here's a picture of several Drupella snails. You can really see the different color variations, and there's a ruler for reference. So what's so special about these snails? Well, they are a nuisance for coral and have continuously been a problem for the health of coral. Drupella snails are coralivores, meaning that they feed on living coral tissue. Not only are they coralivores, but they are obligate coralivores, meaning that their survival depends exclusively on the nutrition they get from feeding on coral and nothing else. They're known to feed primarily on branching, fast-growing corals such as acropora. Here's a picture of acropora. They feed by stripping the tissue from the coral skeleton and leaving white feeding scars that can quickly be covered in algae. Here's a photo of Drupella snails feeding on a branching coral. You can see the white part of the coral is what's been eaten by the Drupella snails, and the brown part is what hasn't been eaten yet. Another fun fact about these snails is that they are nocturnal, so that they only feed at night and like to hide in the crevices and bases of the branching corals in daylight. This is probably why I didn't have much success finding these guys while I was out doing field work during the day. Prior to 1982, Drupella snails had been fairly under the radar as not much information was out there on these snails. However, since then, studies have found Drupella snails in large aggregations in the Indo-Pacific region, such as Australia, Hong Kong, and the Gulf of Thailand, as well as areas outside the Indo-Pacific region, such as Kenya, Japan, and the Red Sea. These snails are best known as a problem species because of their population outbreaks, or overpopulations characterized by rapid change in population density that have been associated with a considerable amount of death of coral. And just for your reference, these outbreaks are usually defined as, on average, more than 3 snails per meter squared. This is significant because corals are the building blocks and the backbone to coral reefs, providing the quintessential habitat for reef organisms. Corals also have a significant impact on us by providing us many ecosystem services, which are positive benefits that the ecosystem provides for humans. Coral reefs provide us ecosystem services in tourism, fisheries, and coastline protection. Recent studies have shown the detrimental effects of continually removing coral tissue on coral health, and it makes sense if you think about it. The Drupella snail plays a direct role in reducing the distribution, abundance, and overall fitness, which is the ability to survive and reproduce, of corals. When Drupella snails feed on coral tissue, it causes corals to redirect their energy to healing and defense mechanisms rather than using that energy for growth, reproduction, and strength. Population outbreaks for Drupella snails occur due to more of the larvae and juveniles surviving. One female can produce over 100,000 eggs. I know, it's a ridiculous amount, but the survival rate of these larvae are incredibly low. In reality, the majority of larvae get eaten by fish and other plankton feeders, including the coral themselves, or they starve to death in clean ocean waters. Do you think you can count how many Drupella snails are in this photo? Yeah, me neither. So why are there suddenly cases of population outbreaks for Drupella snails? The real reason why is still up for debate by scientists, but many believe that these outbreaks are primarily induced by human impacts. Overfishing means that there are less predators to feed on the Drupella larvae. On top of that, development, deforestation, and agriculture all contribute to increased runoff and nutrients in the ocean. This process, known as eutrophication, can act like a fertilizer, causing excess growth of algae, leaving the Drupella larvae with plenty to feed on for it to grow into juvenile and then into an adult. Once they reach the adult stage, there are practically no natural predators that like to feed on them, meaning that populations can get quickly out of control. In this photo, all the green is the algae bloom from eutrophication. As a matter of fact, the threat Drupella snails impose on corals may actually be greater than we originally thought. Before 2010, Drupella snails were only known to feed on branching corals, such as Acropora, as I had shown earlier, as well as Poecilopora and Montipora corals. However, a continuous study was done measuring the abundance of Drupella snails before and after the massive bleaching event in 2010 that I talked about in my second blog post called Coral Bleaching, It's Not a Lost Cause. Check that out if you haven't already. The study indicates that Drupella snails may have a wider range of diet than we originally thought, and thus are indeed quite dangerous to the health of coral reefs in areas where outbreaks occur. This study was done on the small island of Koh Tao in Thailand. Now, it wasn't one of the locations that I studied at for my marine ecology program, but I did get a chance to travel there afterwards and get my PADI open water scuba license. It certainly is a hotspot for divers and snorkelers, with plenty of coral and marine life to see, so I'd highly recommend it if you're into that. So let's backtrack to the bleaching event in 2010. At the peak of the bleaching event, which was around June 15th, 96% of coral cover in Koh Tao was fully or partially bleached. During the study, the species richness of mushroom corals, which is shown above, was assessed at 13 different sites around Koh Tao from June 25th to June 30th, which is right around the peak of the bleaching event. No Drupella snails were found on these corals. The study began in 2006, and from the start of the study to just before the bleaching event of 2010, Drupella were observed preying on Acropora colonies as expected and were not observed on mushroom colonies. Fast forward 5 months to mid-February of 2011. The same 13 sites were surveyed, and there was little recovery of branching corals. At one of the sites, 4 different species of mushroom coral were infested with Drupella snails. This was the first time ever that mushroom corals had been observed to be a source of prey for Drupella snails. A plausible explanation for the Drupella invasion in mushroom coral aggregations was that snails were present on nearby corals before the bleaching started, and switched diet once their preferred food source was no longer available. It's important to note that Acropora are one of the most susceptible to bleaching coral species, while mushroom coral is much less so. Many Acropora corals died in close proximity to the snails and were no longer available as prey. Moreover, many snails had shells longer than 2 centimeters long, indicating that they were more than 2 years old and present before the bleaching had started. Because mushroom corals are less vulnerable to bleaching, they survived and remained available as alternative prey for Drupella snails. So now we know that Drupella snails are not only obligate coralivores, but they are generous coralivores as well, meaning that they can feed on several different species of coral. Their preferred selection of choice seems to be branching coral, such as Acropora or Poecilopora, but they appear to look for an alternative prey when their preferred food is no longer accessible. Now studies have found that Drupella feeding on over 20 genera of corals. This is troubling because a wider range of food means that more species of coral are in danger to the snail's predation. Another reason why Drupella snails pose such a threat to corals came after a study published in 2013, indicating that Drupella snails aided in the transmission of a particular disease hindering coral in Australia's Great Barrier Reef. This disease was known as brown band disease, and is one of 7 coral diseases described on the Great Barrier Reef. As the name of this disease suggests, it is distinguished by a distinctive brown zone caused by dense concentrations of ciliates, or tiny single-cell organisms that ingest the zooxanthellae from the coral tissue. Zooxanthellae are essentially photosynthetic algae that the corals need to survive, and are also what gives coral their color. For more information on zooxanthellae, go back and check out my second blog post. Despite ongoing research on brown band disease, little is known about many aspects of the ecology of this disease, such as its transmission patterns and potential pathogen vectors, or the source that carries and transmits the disease. The only hypothesized vector before this study was once again the vicious crown-of-thorns starfish, as shown here, which produces large feeding scars that have been observed to be the origin of brown band disease. Since Drupella also leave feeding scars on corals, scientists wanted to see if these snails also acted as a disease vector. The design of this experiment is a bit complicated, and I'm not going to go too in detail try and explain all the steps. Essentially, 3 nubbins, or small segments of healthy acropora, symbolized by the H here, were each grouped separately into 4 queen tanks, comprising of 12 nubbins in total. 2 Drupella snails were placed in each tank. At the end of the study, 5 out of the 12 nubbins resulted in feeding scars being the origin of brown band disease from the direct contact of Drupella snails. The experiment was designed so that the Drupella treatment solely caused the disease, eliminating the possibility of direct contact with other infected corals as a source of the disease or the consequence of higher nubbin density. The results show that in more than 40% of the cases, experimental exposure to Drupella resulted in brown band disease. Before this study, it was generally assumed that high coral mortality is a direct consequence of coral tissue removal through feeding. This study highlights an additional mechanism that is likely to significantly contribute to the ecological impact of Drupella outbreaks, which is the ability for Drupella to transmit brown band disease. Injuries to the coral, such as the feeding scars left by the snails, enhance coral disease transmission as they provide entry wounds for pathogens, disrupt the antibacterial mucus layer on the surface of corals, and redirect energy used by corals into the healing processes. So these studies are basically adding more salt to the wound here. Now we know that Drupella snails are generalist, obligate coralivores, and aid in the transmission of a very harmful coral disease. On top of increased bleaching threats, things aren't looking too good here for the coral. So what's being done to reduce the threat of Drupella snails? Unfortunately, management and control methods of Drupella have not been widely documented. The New Haven Diving School in Koh Tao has been one organization that is actively involved in the management of Drupella snail populations. As seen in the study I talked about earlier following the bleaching event of 2010, large populations of Drupella snails were found in the southern part of the island. Immediately after this bleaching event, New Haven research conservation team spent about 41 dive hours and collected well over 15,000 Drupella snails. By 2015, it is estimated that 60,000 snails have been collected by the New Haven research conservation team. Other than physically removing the snails, which requires both a lot of time and people, so far no one has come up with a good large-scale solution to deal with these destructive snails. So hopefully by now you know another threat to coral reefs that is underrated in many circumstances. I'll end by reading a quote from John F. Kennedy. "We are tied to the ocean, and when we go back to the sea, whether it is to sail or to watch, we are going back to whence we came." Thanks.